Okay, we're back for video 5 on lines. This is section 1.2. We'll start with lines and slope. The most important thing about a line is a slope. And what does it mean to have a slope? Well, we can have a positive slope. There's a line. This is my x-axis. That's my y-axis. Positive slope means you're going up from left to right, or you could have a negative slope. That's going down from left to right. There's my x-axis and my y-axis. And of course you can have vertical lines and horizontal lines. A vertical line has no slope. And a horizontal line, this is my x-axis, that's my y-axis, this is my x-axis, this is my y-axis. Horizontal line has zero slope. Right? So positive slope goes up, negative slope goes down. Vertical lines, we don't say they have any slope. Horizontal line has a zero slope. So, like I said, 41 and 42, it's dealing with horizontal lines and vertical lines. So, if we have a point, if you're given a particular point, say 1, 2, 3, 1, 2. So this is the point 3, 2. We'll put a little arrow coming in here. 3 units on the x-axis, 2 units on the y-axis. What's the equation of the vertical line and the horizontal line going through this point? Well, we'll use a red pen for my vertical line. And that's the line x equals 3, right? Because every point on this line has x coordinate 3. And if we use a blue pen for my horizontal line, then this is the line y equals 2. If I pick any point on this line, what's its height above the x-axis? Well, it has height y equals 2. Now, this horizontal line has a y intercept. That's where it crosses the y-axis. Likewise, a vertical line has an x intercept. That's where it crosses the x-axis. Vertical line doesn't have a y-intercept. A horizontal line doesn't have an x-intercept because they don't cross those axes. But if we look at a line with slope, positive slope or negative slope, that's got a x-intercept where it crosses the x-axis, and let's see if we go back to blue for my y-intercepts, they have a y-intercept. So every line that doesn't have a zero slope or no slope, that's not a horizontal line or a vertical line, has got an x-axis and has an x-intercept and a y-intercept. And those are pretty important points. And so problems 41 and 42 are very much like this. If you're given a point, find the equations of the horizontal and vertical lines through that. Okay, so equations of lines, what's slope and all that kind of stuff. Here is the standard, well, not the standard equation, but an equation that you might be very familiar with is y equals mx plus b. That's the equation of the line. M, that's our slope. If it's positive, your line is going up. If it's negative, your line is going down. B is the y-intercept. That's where it crosses the y-axis. And so, again, in section 1.2, problems 5, 6, 9, 10, 17, 18, 21, 22, they all deal with this form of a line. So, here's an example. A line is slope 3/2 and y-intercept minus 3. Write down its equation and sketch a graph of it. So, we'll go back to black. We'll put in our x-axis and our y-axis, and that's where we will put in graph our line. What's the equation? Well, they tell you what the slope is. Slope is 3/2. That goes there for m. Y-intercept is minus 3. That goes in for b. So y equals 3/2 x minus 3. That's our equation. What does the minus 3 tell me? Well, that tells me where the oops, I'm doing y-intercepts in blue. So there's my y-intercept. 1, 2, minus 3. What does the slope of 3 halves tell me? What is 3 halves? Oh, already back in black. So slope is, well, one way to say it, it's rise over run, or slope is change in y divided by change in x. So if I say slope equals 3 halves, then that means I'm going up 3 and right 2. This is referring to vertical, moving up and down along the y-axis. This is moving left and right along the x-axis. So up 3, 1, 2, 3, and then over 2 brings me to this point. That's on the x-axis, so that's actually going to be my x-intercept. And so once I have the x-intercept and the y-intercept, sketching the line is really easy. You just draw a line through those 2 points. And you hope it comes out looking more or less straight. So if I know the slope and the y-intercept, I can write down the line, the equation of the line. Once I know the y-intercept, I know one point on the line. If I've got the slope, that tells me, gives me directions how to start from a point on the line and go to another point on the line. So up 3 and right 2, 1, 2, 3, 1, 2, and that gives me up 3, right 2, and that gives me another point on the line. And once I have 2 points on the line, I can draw the line. So that's what M and B stand for. Okay, here's another line that's actually given to you. Can you figure out what the x-intercept, the y-intercept, the slope, and then y equals mx plus b here? Well, the x-intercept is easy to find because it is right here. It's where it crosses the x-axis, x equals 2. Y-intercept, also pretty easy to find. It's right there. That's actually y equals 5. Great. So that gives us the x-intercept. The x-intercept is 2. The y-intercept is 3. What's the slope? How do I get the slope? Well, the slope is how you go from one point on the line to another point. I've got 2 points on the line. The y-intercept y equals 5, and the x-intercept x equals 2. So what are we doing? We're going down 5 and right 2. So what's my slope? Well, slope equals down 5, that would be minus 5 units on the y-axis, and then underneath we put the how far we go on the x-axis. So slope is minus 5 halves, because we went down 5 over 2, right 2 to get my to go from the y-intercept to the x-intercept. So if you know what the y-intercept is and the x-intercept, you can find the slope. So y equals mx plus b form of the line. Well, we know what the slope is. That's minus 5 halves. We know what the y-intercept is. That was 5. And so now we can just plug those in, and we have the equation of the line. So, not too bad. Okay, another way to write the equation of a line is something called the standard form of a line, and that's ax plus by equals c. And again, this is dealing with problems 1, 2, section 1.2, problems 7, 8, 25, 26, 29, 30, 31, 32. And if you note in the homework, I often pair these things, right? 7, 25, 29, 31, those all have solutions in the back of the book. 8, 26, 30, 32, those are ones that you have to work by yourself and, see if you can get them right without having something to check. So, this is an equation of a line. I want to be able to graph it without putting it into y equals mx plus b form, right? Because there's actually some pretty easy ways to do that. Find the x and y-intercepts and the slope, and then turn it into the y equals mx plus b form. Okay. So what's the x-intercept? It's the point where the line goes through the x-axis. And what does it mean to be on the x-axis? That means you have 0 as your y-coordinate. What's the y-intercept? Well, it's the same thing. It's where it goes through the y-axis. Through y-axis. And that is where x equals 0. Right? So if you're sitting on the y-axis, then your x-coordinate is 0. Okay, so that gives us a way to find intercepts. To find x-intercept, set y equals 0, solve for x. Right? Because the x-intercept is where y equals 0. To find the y-intercept, set x equal to 0, solve for y. Excellent. So we're dealing with the equation 8x plus 3y equals 48. Oops, a little bit too far there. Let's scroll back up. So 8x plus 3y equals 48. To find the x-intercept that, you set y equal to 0, and that gives me 8x equals 48. And I can solve that for x equals 16. How do I find the y-intercept? I look at this equation, and I say, okay, well, let's set x equal to 0, so we ignore the 8x part, and then just we have 3y equals 48. And that tells me that y equals, oh, y is 16, 8 is 6. There we go. Okay. Well, great. We are now back in this situation. We can graph the line because we know the y-intercept and the x-intercept of my line at this point. So if we scroll back down, there we go. We can set up an x-axis and a y-axis. We can put on an x-intercept, which we'll just say is at x equals 6. And we can put on a y-intercept. We'll just say is at y equals 16, and then that means we can draw on our line. So there's our line. That's the equation 8x plus 3y equals 48. Okay, what's the slope of this line? Well, we can find this the same way we found the slope before, right? If we know the y-intercept and the x-intercept, we go down 16, right 6, so slope equals minus 16, because we're going down over 6, which is minus 8 over 3. And notice, and this always happens, if we have ax plus by equals c, the slope is always the coefficient of x divided by the coefficient of y with a minus sign slid in. So we'll make a little note there for ax plus by equals c. We'll make that actually look like an x. Slope equals minus the coefficient of x over the coefficient of y. So there's our slope. So what's the y equals mx plus b form? Well, the slope is minus 8/3. And the y-intercept is 16. So there we have the equation of the slope. So if we've got a line in standard form, you can graph it by finding the x and y-intercepts. You find the x-intercept by setting y equal to 0, solving for x. Find the y-intercept by setting x equal to 0, solving for y. And then you'll find the x-intercepts and the y-intercepts. Once you have those, you can find the slope, and then you can put it into y equals mx plus b form. Okay. Now, suppose they just give you a point and the slope, or they give you 2 points and they want you to find the equation of a line. So 45, 46, 51, 52, 53, 54, that's this section. So example 4, they just give you the slope and a point. So we don't have the y-intercept. We don't know how to find that. But we do know that an equation of a line is y equals minus 2x plus b. We don't know the y-intercept, but we do know that the slope is minus 2. How can we get the y-intercept? We know that the point 2, 5 is on the line. And so that means we can plug in x equals 2, y equals 5 into this equation. And then we can find b. Right. So what we have then is if we plug y equals 5 in, we get 5 equals minus 2 times x, which is 2, plus b. Or 5 equals minus 4 plus b. Adding a 4 to both sides gives me 9 equals b. So what's the equation of my line then? Y equals minus 2x plus 9. So this is very nice. If you know that a point is on the line, that means you can plug those numbers into the line and you get a nice true statement. And so if you don't know what b is, but you do know a point on the line, then you can figure out what b is by plugging in the point. A slightly more complicated version of it is find the line that goes, an equation of the line that goes through these 2 points. So 2, 1 and 5, 13. What do we need? Slope, and we need the y-intercept. And from the previous problems, we know that if we know the slope and a point, we can find the y-intercept, right? Because we just plug in the point into the equation. So first thing we need to do is find the slope. So let's draw a little picture. Right. 1, 2, 1. There's the point 2, 1. Where's the point 5, 13? 1, 2, 3. That's x equals 5. And 13, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So not really to scale because we're just sort of freehanding stuff. So there is my 2 points. This is the point x equals 2, y equals 1. This is the point 5, 13. And we want to know if this is our line here that goes through those points, what's the slope of that line? What does the slope tell us? It tells us how to get from one point on the line to another point on the line. And so we can go over 3 and then up. Well, that's up a total of 12. So right 3, because we start at 2 and go to 5, and up 12, because we start at 1 and then we go to 13, and 13 minus 1 is 12. So slope equals 12 over 3, which equals 4. There's a formula for slope, which is exactly what we've been doing here. If you're given 2 points, traditionally called x0, y0, and x1, comma, y1, and we'll make this look a little bit more like a 0. Then what's your slope? Well, y1 minus y0, that's the change in y, over x1 minus x0. Here, what's my slope? Well, if I take x1, y1 to be this point, then that means y1 is 13, y0 is 1. Right? So this is the height at this point. The height at this point is 1. So we get 13 minus 1. And x1 minus x0. So if this point is x1, its coordinate is 5. If this point is x0, y0, then its coordinate is 2. So 5 over 5 minus 2. Right? That's our up 12 over 3. So a slope is 4. And so this is a formula for, if you've given 2 points, you can find the slope. Usually, I would think of it in terms of a table. If I have a point 5, 13 and 2, 1, then the numerator is this minus this, the denominator is that minus that. So difference of the y's on top, difference of the x's on bottom. Okay, so now we know the slope. It's 5/2. It's 4. We don't know the y-intercept, but we have a point on the line. So we have y equals 4x plus b, semicolon, 2, 1 is on the line. And so now we are back in this equation. We know the slope, and we know the point. Not that equation, but that problem. So if we scroll back down here, what is b? Plug in 1 for y, plug in 2 for x. 1 equals 8 plus b, so b equals minus 7. And finally, the equation of the line is y equals 4x minus 7. Okay, so given 2 points, you can find the slope. 13 minus 1 divided by 5 minus 2. You can think of it as going over 3 and up 12. Right? Up 12 over 3. Or you can use this formula. Slope is y1 minus y0 over x1 minus x0. Well, that's 2 points. Okay, and so that gives us the equation of the line. And of course, then we have these word problems, because every section has word problems. And here the question is, all the problems in section 1.2 deal with lines. So in this example, we have a coffee shop that's got a fixed cost of $100 a day, variable cost of 25 cents, right, $0.25 per cup of coffee. We want to know what's the total daily cost of producing X cups of coffee. And then how much does it cost to produce 100 cups? How many cups of coffee can you make for $150? So if you make 100 cups, how much will that cost you? If you have $150 as your budget, how many cups of coffee can you make? So in dealing with these business-oriented problems like this, what's a variable cost? Well, a variable cost is something that depends on how many cups of coffee, in this problem, how many cups of coffee you make. Right? So coffee itself, for example, or filters, or, well, in my case, sugar, right? Those are all things that depend on, those costs depend on how many cups of coffee you make. Each cup of coffee costs a certain amount. In this problem, each cup of coffee costs $0.25 to make. Fixed costs, those are things that you have to pay even if you don't make any coffee at all, right? If you own a store, regardless of whether you make any, whether you sell anything, regardless of even if you open, you have to pay for rent, you have to pay for utilities, you have to pay a lot of fixed costs that have nothing to do with how you, how many cups of coffee you sell. So, in general, variable costs are slope, fixed costs are y-intercept. So here, right, we're trying to find the total daily cost of producing X cups of coffees. So cost, total costs, equals variable costs plus fixed costs. Right? That's the only type of costs you have, right? Costs that depend on how much you sell and costs that don't. So if we take C to be total cost, then your variable cost is 0.25 X, because X is the number of coffees cups of coffee you make. Each one costs you 25 cents. So if you make X cups of coffee, this is how much that costs you, plus whatever your fixed costs are, regardless of how much you make of coffee. So that's $100. And look at the units a little bit. Costs, that's in dollars. Fixed costs, well, that's definitely in dollars. This whole thing, right, it's your variable costs, so that better be in dollars as well. But the units of X is cups, right, number of cups of coffee. What's the units of the variable cost? Well, it's dollars per cup. And so if you think about the units for a second, what that tells you is that dollars per cup times cup, well, the cups cancel out, and the units of this whole thing is dollars. So variable costs are slope. Slope usually has units of, this per that, because it's a fraction. Y-intercept is just units of, in this case, dollars. So that's your equation. Note that if X equals 0, right? If this is 0, then your cost is $100. That's your fixed cost. But when X equals 0, that tells you what the Y-intercept is. Setting X equal to 0, find the Y-intercept. So the Y-intercept is actually your fixed cost here. Okay, so then the second part of the problem wants to know, if you produce 100 cups of coffee, how much does that cost? And if you have $150, how many cups of coffee can you make? So if X equals 100, so you're making 100 cups of coffee, then C equals 0.25 times 100 plus 100, which is 125. So to make 100 cups of coffee, you make $25 in variable costs plus the $100 in fixed costs. That's just supposed to be a dot, and I'm just making it worse, aren't I? 0.25. And $100 in fixed costs, so that gives you $125. Now, the other part was, if C equals 150, if you have $150, how many cups of coffee can you make? What's X? Well, then, if we plug that in, 150 equals 0.25x plus 100. If I subtract 100 from both sides, I get 50 equals 0.25x. And then dividing both sides by 0.25 gives me 200 cups. So I can make 200 cups of coffee for $150. Of the $150, $100 goes to my fixed costs, $50 goes to making cups of coffee. Each cup of coffee costs me a quarter, so for $50 I can make 200 of them. Okay, so here, once we have the equation, 100 cups of coffee, that goes in for X. $150, that's my total cost, so that goes in for C in the problem. Okay. A two-point cost analysis. This is problem 63, 64, 67, and 68. You'll see why I call this a two-point cost analysis in a moment. So a donut shop buys a fryer, a deep fat fryer or something, for $1,500. The fryer has a trade-in value of $600 after 5 years. And the owner uses a constant rate of depreciation to determine the annual value of the fryer. What does that mean? Well, if you're owning a business, you can get a tax write-off on, maintaining your physical plant, and you have to be able to say how much it's worth. By saying that something has a constant rate of depreciation, that means each year it loses the same amount of value, right? Each year it loses $50 worth of value. Each year it loses $100 worth of value, or something like that. So that's what a constant rate of depreciation is. So what we want to do is find a linear model for the value V of the fryer T years after it is purchased. And then how much is it worth after 3 years? When will it be worth $100? These two are very much like the last two questions in the previous problem, right? We have an equation that will involve V and T. Here they're saying when T is 3, what's V? When V is 100, what's T? Okay. Great. So what's going on here? They give us two pieces of data. One is that when you buy it at T equals 0, it's worth $1,500. And that 5 years later, it's worth $600. So what do we have? We have 2 points. That's what's called two-point cost analysis. 0 comma 1500 is 1 point, 5 comma 600 is another point. Right? So if we wanted to sketch this line, what would it look like? Well, the y-intercept would be 1500, because it's the point 0 comma 1500. That's my, well, this is my t-axis, this is my v-axis. When t equals 0, 1500 is the value, and that's where it crosses the vertical axis, so that's my v-intercept in this problem. And then 5, 600, and that's another point on the line. So what we have is 2 points on a line, and we want to know what the equation of the line is, and that is the same as the previous problem we've done. What's my slope? Well, 1500 minus 600, 1500, this minus this, divided by this minus this. Make sure you keep the order of your points correct, right? 1500 and 0 are the first two, and the 605 are the second two, because we need a line that's got negative slope. This is a line going down. If you get things backwards, this sign will change. So this is 900 over minus 5, which is minus 180. And what's the units of that? Well, the units of V, that's dollars, and the units of T is years. So dollars per year. My fryer loses $180 in value each year. Excellent. So value is, we know the slope is minus 180, T, and we know the y-intercept is 1500. So there's the equation of value. Then we want to know when T is 3, what is V? So after 3 years, V equals minus 180 times 3 plus 1500, and that is 960. This is how much value your fryer has lost in 3 years. And the second question was, if V is 100, how many years have gone by? So we plug in 100 for V, and we get 100 equals minus 180T plus 1500. And if we subtract a 1500 from both sides, we get 1400 equals minus 180T, and then divide both sides by 180, and you get 7.77 ... equals T, which is about 7 years, 9 months, and 10 days if you actually grind it out. So after about 7 years and 9 months, it'll be worth about $100. And if they keep going, you know, after a while it'll actually be worth nothing. Okay, equilibrium analysis. This is actually very much like the previous problem. It's secretly a 2-point problem. So supply, that's how much people want to sell. Demand is how much people want to buy. Now if the price of something goes up, people want to supply more, right? Because suppliers, if the price goes up, you want to put more out in the market so you can make more money. On the other hand, when the price goes up, demand goes down, right? People want to buy less stuff because it's more expensive. And equilibrium, when you're doing market analysis, equilibrium is when supply equals demand. And the idea behind market analysis for economists is that markets try to get to equilibrium. They try to have supply equals demand. It doesn't always work in the real world, but in theory, it's nice. So here's a problem. When price is 75 cents a donut, in a small college town, the supply of donuts is 480, the demand is 520. If the price goes up to 115, the supply goes up to 600, 480 to 600. The supply people want to sell more, but the demand drops from 520 to 460. Right? People want to buy less donuts. So, assuming that supply is linearly related to price, find a model of the form P equals mx plus b for supply. Here, P is your price, X is quantity of donuts supplied. Right? That's the supply side equation. Okay, so let's look at supply. What do we know about supply from this problem? Well, they give us what our variables are. They're P and they're X. So this is X, this is P. P is price, X is quantity of donuts supplied. And what do we know about that? Well, when the price is 0.75, the supply is 480. And when the price is 1.15, the supply is 600. And what do we want? P equals mx plus b. We need slope, we need y-intercept. 2 points, we can find the slope. So 0.75 minus 1.15, this minus that, divided by this minus that, over 480 minus 600. And if you grind that out, that's 1 over 300 dollars per donut. And that's dollars per donut supplied. Economists, from a mathematician's point of view, economists always set up their equations backwards. Usually we would think of supply responding to price rather than price responding to supply, but you can do it either way. One easier way to think about this is if you think about the reciprocal, that would be 300 donuts per dollar. If the price goes up by $1, the number of donuts supplied will go up by 300. And that's the correct sign, right? Because we want to have a positive slope. If the price goes up, supply should go up. Okay, so now we know that 1 over 300 x plus b. How do we find the y-intercept? Well, we've done this a couple of times now. We take a point and we plug it in for x and p, and then we find out what b is. So in this case, I will take this point, plug in x equals 600 and p equals 115. 1.15 equals 1 over 300 times 600 plus b, and that gives me, right, so a little arrow going over that way, b equals, if you divide this and move the 2 over, minus 0.85, which I'll write is a fraction, minus 17 over 20. You can do this whole problem in decimals if you want. I'm going to do it in fractions. So, supply equation. Oops. Price equals 1 over 300 x minus 17 over 20. Right? And if x equals 0, then p equals minus 17 over 20. When the price is negative, right, and you're paying people to take stuff away, then the supply drops down to 0. Okay, so there's my supply equation. What's my demand equation? Well, same sort of thing. We can set up a little table. The demand equation had at 75 cents, so this is price, this is x. Now this x here is quantity demanded. This x was quantity supplied. 520, and when the price rose to 1.15, the quantity demanded dropped to 460. So we can do the same thing. Slope is 0.75 minus 1.15 divided by 520 over 460. And if you calculate that out, that will be minus 1 over 150, and that's in dollars over donuts demanded. And again, this is a little bit easier if you think about the reciprocal of this. That would be minus 150 donuts per dollar. And so that means if the price goes up by $1, the demand goes down by 150 donuts. Okay. So the demand curve is P equals, I don't know what happened to my D there, P equals minus 1 over 150 x plus B. How do we find B? Pick a point and plug it in. And again, I'm going to take this point and plug that in. And that gives me 1.15 equals minus 1 over 150x plus b. And solving for b, again, if you make this a fraction, you should get 253 over 60, which is about 4.216. Dot, 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 dot. It's just repeating sixes all the way out. So the demand curve then is P equals minus 1 over 150 x plus 253 over 60. Okay, so equilibrium is where demand equals supply. So we're coming to the end of my little page here, so that means this minus 150x plus 253 over 60, that's my demand, should equal my supply, which is 1 over 300x, what was it, minus 17 over 20. And you can solve for x. Move all the x's to one side, all the constants to the other side, and you'll get x equals 1520 over 3, which equals 506 plus 2/3, which is 506.66, dot, 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 dot. So if you're doing this with a calculator, you should get some number close to 506.6666. You know, I don't know exactly what you get. It depends on how you rounded it. Once we know x, we can plug this number back into either the demand equation or the supply equation to find my equilibrium price. And if you plug that in, you should get P is 151 over 180, which equals roughly 0.8388 dot, 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 dot. So what's my equilibrium? Equilibrium price is about 84 cents. Equilibrium quantity is about 507 donuts. So what's this equilibrium mean? If the price is 84 cents, then 507 donuts is what the suppliers want to supply. 507 donuts is what the demanders want to demand at that price level. And so we're in equilibrium because everybody's happy about that. Okay, so lines, slope,